Passing an element of an array to a function as an argument is one thing. So for example, in this program here, I have void print score, and then I have a formal parameter, an integer called score, and I simply do a line output here, and then I do console output the score is, and then I print it out, right? It's a very simple example. In main, I have an array called scores, and I just entered a couple of random integers in there. Of course, you can go and write a program that enters it from the keyboard and everything, but as always, I'm trying to keep these things as concise as I can. So let's just call that print score function, and as an argument, we can specify the scores array and then pass in an index. So let's say we want to print out element number 3, for example, 0, 1, 2, 3, we should get 22. Build and run that. And that is what we get. The score is 22. I can remove this line here. This is actually just a bonus section that I did after actually recording the rest of the lecture here. So that's why that line was still left in there. Now, as we can see here, the print score function call, we can specify an element in the array, because all that's going to do is it's going to fetch that particular element. So in this case, it's going to fetch the integer 22. It will create a copy of that because this is a value parameter. The score here will basically be initialized to 22 and we'll print it out again. After the function call, that local variable is destroyed again. Alright, so this is one thing, but what if we want a parameter in a function? So print score here, let's say we want to do scores like that. Right, let's say we have an array in a function, a parent function such as main, and we want the function that we call to maybe loop through it. So in this case, print scores, we want this function to loop through and print out every element in this array. Because of course this function doesn't have access to this now, we have to pass it into the function. And how does that work? How can we pass an array as an argument to a function? And then also, what will the function parameters look like? That is really what this video is going to cover. We use array formal parameters or pointers to accept arrays as function arguments. I have an example here, so int print scores, just the function declaration, and this has an array parameter called scores. It's important that the type matches the argument that you pass in, so if you have an array of integers that you pass in as an argument to this function, that has to match with the parameter. Now this parameter is constant because we are going to print the elements out, so we're not actually going to make changes in this function, right? We are just going to do console output. And we'll actually look at this in Visual Studio here in the next example. So again, this is referred to as an array parameter as opposed to a reference parameter or a value parameter or a pointer parameter. Now the second example actually has a pointer parameter. Now we've talked about that relationship between pointers and arrays. When you have a pointer that points to some array, that you can use the subscript operator with that pointer name and so on. So we've already discussed that. And in the upcoming examples, I'll show you that again. Now using an array formal parameter, the entire array is not copied, but instead the parameter acts like a reference parameter as opposed to a value parameter. So the function will only receive the address of the first element of the array argument. We do not specify the size in the array parameter. We can specify another formal parameter for the size of the array, and this means that we can use the same function with different arrays of varying sizes. Another important thing here is that in the function call we pass only the name of the array, so that is without the subscript operator. Okay, in this first example I have a global variable called size. It's a constant integer which I set to 3, so that is accessible in all of these functions, including in the main function, right? Actually, I'll just go back to main. You can see I have an array of integers which I called scores, and here I call these two functions input scores, right? We want to input a couple of scores into an array, and then we simply want to print those out again. So input scores and then print scores. And you can see in both cases I simply pass in the name of that array in here, so the array identifier, and I declare the scores array to be of size, so here I set that to 3. So I have the input scores function right here. It takes in, where it has a formal parameter int scores and then p. Okay, and I also have the opening and closing brackets, but you can see that I don't pass size in here, so I leave this empty. And this is very handy because it means that we can use this function with arrays of different sizes. So I do console output, enter so many, in this case 3 scores, and here just do the for loop, console input scores p, and then I. Okay, that iterator I'll pass in here. We start at 0, 1 and 2, altogether for 3 elements. Now in print scores I'm going to do something similar, but in this case it's going to be constant, because we don't want to make changes to that array, right? We simply want to print it out. I print out this line, and then I do console output, the scores are, and then I simply do the for loop again, but in this case I print it out. So console output scores p for parameter, and then I pass in the iterator I. Once I'm done, I just do another console output. Let's see what happens. I'll then run that. I'll enter a value, press spacebar, enter another value, press spacebar, and enter another value. In this case 2, 5, and 4. Press enter and it will print this out. These scores are 2, 5, and 4. Of course you can change the format and everything if you want. This is just a quick example. So actually let's go and remove this const here. And then here I'll change one of the elements, so scores p for parameter 0, I'll set that to 300. Pull and run that again, and you'll see we get 300, 3 and 6 printed out, instead of 5, 3 and 6. Now actually I'm just going to add the end here. I'll just add this quick tab here so it's easier to read. But the point here is that we can change that. So this input scores will actually affect this scores array in main, which is going to be the calling function for input scores. Then we go and print that out again. So we call print scores. We pass in that scores array. But here we can now actually make changes to it. How can we avoid that? Well, we add const. If you bull and run now, of course, you'll get an error. You cannot assign to a variable that is const. Okay, so we cannot do this. So that is one way the programmer can enforce essentially a constant reference. And as you can see from this example, you are actually affecting the array here in main. So you input the scores that will get stored in this array, and then we print it out again using another function where we specify scores p, this array. This is similar to a reference, and this means it doesn't copy the entire array over for performance reasons. It doesn't actually make a copy of the entire array, because an array can be huge and contain many variables, and not just of the basic types. You can have arrays of custom types such as structs and classes, of course, as well, and that means that array can be huge, so copying it around is not efficient, and for that reason this acts more like a reference, so a pass by reference as opposed to a pass by value. Instead of doing this here, I can also, actually I'll just leave it const. I'll remove those. I'll remove the subscript operator. For print scores only, I'll do a pointer to an integer constant. I'll call this scores p once more, and here I'll remove that. I'll increment it, and I'll dereference it. So we covered pointer arithmetic in a previous lecture, and you can see what's happening here. Again, we dereference this pointer. So in other words, we'll print out whatever it is pointing at, and then we add some offset to that pointer, so it's going to point to the next element. So let's just see how that works. And you'll see those get printed out. The scores are 5, 3, and 8. So I just wanted to provide another quick example of this. Okay, a couple more things to note here. You might think with this syntax, you might think to do this. So do the dereferencing of that pointer first and then do the increment. But you'll see you'll actually get an error here. If you try and build and run this, you'll get an error. And the reason is we are doing the dereferencing. So we are fetching whatever that is pointing to, and then we are trying to increment that. But we have const here. If you take const away, then this will be fine. That will go away. So why is that exactly? Well, we have a pointer to an integer constant or a constant integer. So in other words, we can change the pointer, but we cannot go and indirectly change the variable or whatever that pointer is pointing at. And remember the prefix and postfix. This is a postfix, so here it's going to print this out. It's going to fetch whatever this pointer points at. It's going to print it out, and then when it's done with that, it's going to increment the pointer. So it's going to add an offset based on the type. The type is an integer, so it's going to add 4 bytes of offset, right, as I explained in some of the previous lectures. And that's why this statement here works, as I showed you previously. Right. And from the lecture on the relationship between arrays and pointers, you'll also notice that we don't really need this complex syntax. You can remove that, use the subscript operator, and then pass in I, basically as we had it before, and that will work fine too. Because again, we can use that subscript operator with a pointer, as I explained in some of the previous lectures as well. And that will print those scores out. Okay, I'll just change this back here to an array argument. So it's best to think of these as array arguments. Now with the regular arrays, so when you declare an array and so on, you have to specify the size, right? But as a parameter, again, we don't specify the size. You can actually specify the size, but that will typically be ignored by the compiler. So for the most part, we don't specify those when we write array parameters. So as we've seen, it's almost like having a pointer in here as opposed to an actual array. We don't copy the entire object over or the entire array over. We essentially return the address to that array in this formal parameter. So just for fun, what you can do is we can go and print out the size of that scores parameter. I'll copy that, go back to main, and in this case I'll do the size of scores, so I'll print that out. Let's pull and run that. So of course this is just a quick demo. You can enter out the size of the array is, and then it will give you the values. In this case it's 12. I'll just enter a few numbers here, and then once it's done with that loop, the for loop in the input, okay, that is where we do the console output. So we'll get 4, and if you remember, that is the size of a pointer. So instead of copying 12 bytes over, we only have 4 bytes in there. So it's more memory efficient. Again, these arrays can get huge, especially if you have arrays of custom types such as structs and classes, as I mentioned previously as well. So just a quick bonus demonstration. Remember, I added the size of in input scores, and then in main here as well. Now what's useful about array arguments and passing arrays to functions to operate on those arrays is that we can pass different arrays of different sizes to those functions. Of course your type should match, so integer here, and the array right here is also an array of integers. But let's say we have multiple arrays of integers, so scores 1, scores 2, and so on. You can pass them into the same function, and even if they are different sizes, the function will still accept that array. But currently we have a bit of a problem with this example because we specify the size as a global constant integer. So as an exercise for you, what I'd like you to try and do is to change this program so that the functions can accept arrays of different sizes. So think for a second how you can do that. So here, for example, we have size, which is again a global variable. And so how can we solve this issue? Because that's not useful. Let's say I pass in an array to this function that has, let's say, 5 elements instead of 3. It's still only going to use this 3 here and only iterate through the first 3 elements. And it's even worse when you pass in an array that has only 2 elements, but you iterate through 3 or 4 elements. So you might be accessing things that you should not, right? So try and solve that problem, and when we come back I'll show you how we can do this. Okay, I'll start by removing that global variable, and I'll create a parameter instead for each function. Of course we want to do it in input scores and in print scores. I'll just start here with input scores, and then you need to make sure to change those instances. So size right here and right here. And then in print scores, something similar. You can do size. Okay, so we've replaced our size, capital size here with lowercase basically, and we have the parameters for size in each function. Then I'll actually just paste this constant integer that I cut out previously, and I'll call this something like array size 1, and scores, I'll change that to scores 1. Paste that in here. In Module 101 on the lessons on arrays, I talked about how it's useful to have a constant integer that you can use to specify the size of the array, or in other words how many elements that array will have. And again, the reason for that is you may use that size later on in the program, including, as we saw previously, in for loops for example, and so on. So this is another place where that is useful. So we specify scores, the array, and then we specify that size. So array size 1. I'll actually just copy and paste that and create scores 2 maybe. I'll change the size of that to maybe 5. And I'll specify a few elements. We know that this array has these 3 elements that we specified, and of course the rest will be 0. And all I'm going to do with this is I'm going to print it out. And we need to make sure to set the size correctly. So constant int array size 2, we want to specify this array to have the correct size. And all I'm going to do is print scores, and I pass the array name and the size. And just one more look at the functions. Again, it's going to take in an array argument and the size of that array. And this again allows us to use the same function on different arrays with the same type, but they may have different sizes. Now I mentioned that I need to have the same type. So if I go and change the type of the array to a float, for example, try and build and run that and you'll get an error. Cannot convert argument from float to a constant integer, something like that. So again, you'll get an error because of that. Just change that back. That should work fine. So as you can see, it prints out the values that we entered, 8, 9, and 15. Then we went and specified another array with 5 elements. We specified the first 3 elements to be 2, 3, and 4. And you'll see the rest will be set to 0. So this works fine. It shows us that we can call the same functions with different sizes of arrays. The only thing is those types need to match. Alright, so that is going to wrap up this video.